Alright, are we live? So that's a little embarrassing. Oh man. Uh-oh. So basically, a little embarrassing, but what I did is I forgot to not full screen it. So yeah, sorry about that. I did a whole 35 minutes and did not go from full screen to normal so you can see what I'm doing. Forgive me for that. I'm sorry. Well, here's the it works. It's pretty quick. Alright, brother. So we'll start over, explain the problem, and then I'll just explain the solution. It took me quite a bit of finagling to get it right. Yeah. Given two 1D vectors, implement an iterator to return their elements alternately. Input v1, 1, 2, v2, 3, 4, 5, 6. Output 1, 3, 2, 4, 5, 6. So you get 1, 1, should be 1, 3, 2, 4, and 5, 6. 1, 3, 2, 4, 5, 6. By calling next repeatedly until has next returns false, the order of elements returned by next should be 1, 3, 2, 4, 5, 6. Right? And then the follow-up question is, so hopefully that makes sense. Follow-up is, what if you are given k 1D vectors? How well can your code be extended to such cases? Clarification for the follow-up question. The zigzag order is not clearly defined and is ambiguous for k greater than 2 cases. Zigzag does not look right to you. You replace zigzag with cyclic. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be 1, 4, 8, 2, 5, 9, 3, 6, 7. Right? 1, 4, 8, 2, 5, 9, 3, 6, 7. Right? So really a cyclic version of with more than one vector. That's basically what they're asking. That's a great. I'll code up my program keeping that in mind. That you may want to generalize that case where you have k vectors rather than just 2. And I went ahead and did that. And the solution, in simple terms, is like basically you have a list. So you're going to have a bunch of iterators for each vector. You have iterators for each vector, one pointing to the beginning, one pointing to the end. And I'm going to use pairs of these iterators for each vector. And then I'm going to use, so this will kind of keep track of the positions for the vectors. And then I'm going to put all those into a list, a linked list. Each pair in its own linked list node. And the idea is that I can just very easily build the list by adding each of those pairs. And then when I want to get the next value, and I just start at the first pair, and the first sort of every iterator, by the way, is going to start at the beginning of each vector. And what we're going to look to do is when you want the next value, you're going to say, okay, if for my linked list, take from the pair, take that first position, that first value, increment that iterator to the next value, return the number that was there, so the number that's pointing to, take that number, increment to the next, and then we're going to, by the way, if that was the last element, we want to remove that node from the linked list. That's why we want to use a linked list. It's, easy removal. And we want to go to the next node, right? In any case, we want to go to the next node. But if that, in particular, if we have finished that sort of that vector, all those elements of that vector, then we want to remove that node. And we also want to wrap around to the beginning of the list again. Each time we jump down, we grab an element and we move our iterator in the linked list down, and we also move the iterator in that particular node that represents that vector, move that over as well. We want to wrap around our the linked list iterator, so that way it's cyclic as described. Wrap around to the beginning of the linked list, and that's pretty much it. You just keep going, until obviously each of these vectors, they have different sizes. So these nodes are going to kind of disappear out of the list sort of at different times. And eventually, once you get all the way through, you end up in a position where your pointer to the linked list, the beginning is also the end, right? It's an empty linked list, and at that point, we don't have any more nodes to look at. So that's their has next is when we're not pointing to the end, and we never really should point to the end. Every time we point to the end, we end up wrapping around back to the beginning. And there's just some code to kind of handle each of those things. So here you have the iterator to the current position in your linked list, which is just a linked list of indices. And these indices, I type def them. They're a pair. One vector of integers iterator, and another is a const iterator, which is this is going to be the ending for each vector. So we don't have to store anything in our iterator other than the list of pairs of iterators and an iterator in that list. Of the vectors themselves, they're going to be, they're stored off in somewhere else in memory, so we don't really need to know anything about the vectors themselves. Just these iterators. And obviously, if they're empty, we just don't push the node in at all because it gets kind of wonky, kind of confusing. Technically, you can push empty. Like I didn't really work that out exactly, so the code got kind of funky when I had empty lists. But this does technically handle that. It's sort of a sanity check here. If that particular node that you're looking at is already pointing to the end, then you do some stuff here. I think you get current, you erase current, so current equal to temp, and then wrap around as needed. It's the ending, it's the beginning. Yeah, the thing that's funky about this is you would call next again. However, if there were no values in, that's why we run into problems. If you never had any values to begin with, then you get some weird things. You actually, so this calls next over and over until hasNext returns false. This sort of sanity check here on a whole bunch of empty arrays will actually cause problems. It's better to just never put them in there in the first place. But basically, if the whole thing's empty to begin with, because this is going to call next on effectively an empty list, and we don't have anything to return. We shouldn't return anything. We shouldn't even call next. Really, hasNext should just be false out the gate in this situation. So really, this is kind of interesting. I don't actually know what you do here. I mean, this kind of shouldn't happen, basically. I don't know, this code's kind of bunk. I gotta think about that actually a little bit more. I didn't really want to think about this problem too much. But, so are we still, yeah, okay. I mean, we really don't need this, do we? As long as you don't put any empty nodes in there in the first place, then you really don't have anything to worry about. Yeah, because you clean up the empty ones as you're going, so it's not really a problem. Shouldn't be a problem. Yeah. Okay. Anyway. So yeah, so basically, you have a sanity check for a runtime issue. If it's already empty, and you call this, then It's just runtime error. If you're not empty, then right. So you're going to say get the pair, whatever the iterator is pointing to in the linked list. We're going to get that pair, reference that pair. We're going to say the return value is going to be whatever that pair's first value. That is an iterator into the actual vector. So we're going to get that value from the vector. Then we're going to update that pointer to the next one. Then we're going to we're going to say get a temporary pointer to that linked list node. Update that to the next spot too. And then we're just going to do a quick check to see if the node that we're just looking at, the current node, is now sort of expired, right? We move the iterator out to the end. Then we're going to remove the linked list. Now we're going to update our current value to that temporary value, which we said is just advanced one value. And then we're going to wrap it around if it's at the end of our linked list, set it to the beginning, and then return that value that we already grabbed. And that should do it. It's really pretty simple, pretty straightforward. I like hitting the submit button a bunch of times. But yeah, I had to explain it again because we didn't get 8 milliseconds. Because I keep hitting it over and over to get 8. Come on, give me 8. Give me 8. All right, whatever. I don't know. Maybe that code we needed it. Maybe it did something for us that I missed. But yeah. So oh, you know what's weird? Wait, why? Hold on a second. Why? Oh, right. We don't even put the empty ones in there. Yeah, I forgot. Okay. Yeah, once it gets empty, it just gets removed immediately, so that's okay. Never mind. So what I would like to do is go to the next problem. Yeah. Didn't want to have a totally. Where are we? I didn't want to have just an empty video where I had no explanation. So yeah, thanks for watching. Hopefully that very brief, very quick explanation is sufficient. That took me forever to code. Yeah, hope that's good. All right, take care.